Good morning everyone. Today we will conduct one more experiment, the sixth experiment in our electrical machine 1 lab, that is SCOTT connection for balanced and unbalanced load. The main aim of the experiment is to obtain the two single phase supplies from a three phase supply by SCOTT connecting the two transformers and further study the loading on three phase side due to the loading on the two single phase sides and determining its efficiency of the combined set. The overall circuit diagram to conduct this experiment is shown here. We will be using two transformers basically, the main transformer and a teaser transformer. Main transformer will be having a tapping of 86.6% and the teaser transformer will be having a 50% tapping. Here also we will be using two wattmeters to measure the input power and we will be having a voltmeter and ammeter to measure input voltage and current. Then of course we will be using one three-phase auto transformer which can be excited by means of a three-phase supply. And at the right hand side, at the secondary side, we will be using two loads, single phase loads, where exactly we can use an ammeter voltmeter connection to measure the voltage and current drawn by the single phase transformers. This is the overall setup what we have to conduct a SCOTT connection. T1 will be the main transformer and we will be having T3 as a teaser transformer. Of course we will be using a load here. Here we will be having a load which can resistive load of 3 HP and 10 amperes. This load can be utilized as a single phase load as well as three phase load. If we use only these two connections to connect phase and neutral of a load side, it can be named as a single phase load. And if we short one of the terminals, all these R, Y, B terminals, and if you use only this R, Y, B, it can be considered as a three phase load. So now for our SCOTT connection, we will be using these two terminals for one phase and these two terminals for the second phase. And just by adding these switches, we can apply the load. And the load current can be measured by respective ammeters. Now let's see how exactly the connection goes. First we will be giving supply from mains to a auto transformer. Again RYB supply will be given to the auto transformer. The transformers which we use to conduct this experiment are having a rating of 3 kVA and 220 volt. Now from RYB the supply is given to the auto transformer. You can use a lengthy RYB wires to auto transformer input terminal. So we should carefully connect this input terminals and output terminals of auto transformer carefully. Again from the output terminals RYB connections are taken. So now R phase should be given to through ammeter. It should be connected to wattmeter. First terminal of the ammeter R phase, and then ammeter next terminal should goes to the wattmeter M terminal, and then MC should be shorted, and next L terminal should goes to the main transformer tapping of 86.6%. Now secondary side we should give S1 S2 side, and then from S2 should goes to the teaser transformer 50% side, 50%, and then next from Y phase 2 should be given to the S1 terminal of a teaser transformer, and then the V and V of both the wattmeter should be shorted, and one terminal should be given to again S1 of the teaser transformer. So here VV of the wattmeters are shorted. Again one more wire is going to S1 terminal of a teaser transformer. And next from B phase of a auto transformer. B phase of the auto transformer should be given to M terminal of the wattmeter 2. Again MC should be shorted. Again L terminal should goes to L of the wattmeter 2 should goes to S2 of the teaser transformer, and here S1 terminal of a main transformer should be open, so we should note of it. Now let's see how exactly the loads are connected to the primaries of the main and teaser transformers. So P1 P2, from P1 to ammeter to load, again load back to P2 of the main transformer, again similarly from P1 to load, again load back to ammeter to P2 of the teaser transformer. We'll see. So again we'll be using ammeters to measure the current drawn by each loads, and voltmeter we can connect across the load, or we can connect across P1 P2 also. Now for our case of use, we will connect this voltmeter, both the voltmeters, across P1 P2 of the main transformer, again the one more voltmeter across P1 P2 of the teaser transformer. Now from P1 of the main transformer should goes to the ammeter 1, I1, this is the I1, and then another terminal from ammeter should come back to the load size. And as I told you, any two terminals can be used as a single phase load. Another terminal from the load should goes back to the P2. Now we can connect the voltmeters, we can connect it later, anyhow it's a parallel connection. Now next the second load is connected from P1 terminal of a teaser transformer to ammeter, which measures the current I2, and then another terminal from ammeter should come back to the second terminals we use is as a load, and another terminal of the load should goes back to the P2 terminal of a teaser transformer. So this is how exactly we have connected the load in series. Now we have to use the voltmeter across P1 P2 of main and teaser transformer. One voltmeter should be connected to P1 P2 of teaser transformer first, and then one more voltmeter
is range 300,
which is having a range of, we are using a range from 0 to 300 volt. Anyhow we are converting from single to three phase, three phase to two phases, so 0 to 300 range is enough for both the voltmeters, and even the ammeter ranges are selected as 0 to 10 amperes. 0 to 10 amperes range we will select for both the load side ammeters. This is what the overall connection what we make to have a SCOTT connected transformer for conversion from 3 phase to 2 phases. Let's see how exactly the conduction goes. Main transformer T1 and the teaser transformer T2. Both the transformer are having a rating of 3 kVA and 220 volt. So here at the secondary of the T1 we have used 86.6% of tapping, and at the main transformer, teaser transformer, we will be having 50% tapping. So before starting the procedure, we should confirm that the 3-phase auto transformer should be kept at 0 position. If not, we should make the auto transformer, 3-phase auto transformer 0, and then we have to switch on the 3-phase supply. After confirming the transformer 0 position, we can switch on the 3-phase supply. Now gradually vary the auto transformer from its 0 position till the voltmeters V1, V2 connected across the load should show 230. Vary the auto transformer gradually and see that V1 and V2 shows 230 volt. So V1 is showing 230 and V2 also showing around 230. Once the rated voltage are applied, then vary the load in steps. First we have to apply the balanced load for transformer 1 and transformer 2. means put on 2 switches for transformer 1 and 2 switches each for transformer 2. Then note down the value of W1 and the reading of W2 and the current drawn from the transformer I1 and I2. The corresponding V1 and V2 readings are also noted down. The loads are applied in steps to take the balanced load reading. So 2 loads each are applied and corresponding W1, W2, I1, I2 and V1, V2 readings are noted down. All the readings are tabulated in the tabular column provided in the manual. That is for balanced load. Again, for unbalanced load, the same procedure is repeated by applying the unequal loads in the load. So 2 switches for the transformer 1 and 4 switches are on in the load for transformer 2. The corresponding values of W1, W2, again I1, I2s are noted down, and V1, V2. And for 4 to 5 readings are noted down for unbalanced load also. And finally, the calculations are made by using the formulas provided in the manual. Then efficiency of the transformer for balanced as well as unbalanced load are calculated. The main intention of this conducting experiment is to convert a 3-phase supply into 2 single-phase supplies, and 2 single-phase supplies are helpful in furnaces to heating up of iron ores. So this completes the SCOTT connection on 3-phase transformer.